Hi, welcome to the Honors Chemistry Wednesday, September 16th video, sorry. This video is for folks who were absent, who missed class, or for those people who were in class but may have missed something and want to see it again. Okay, so our objectives for today were to review the schedule, review nuclear chemistry stuff, and go over expectations for the Unit 1 final project. Now, there's a separate video where I talk more about the Unit 1 final project and some details, so this video will just give you a general idea of what was covered, but more details in a second video, so look out for that. All right, the first objective was to review the new schedule. So as I said, the new support hour schedules have started. Essentially, whatever day you don't have a class is the day that you have support hours for that class. And the support hours have a specific chunk or block of time. For example, in our class, block 2, we have support hours on Tuesday and Friday between 1:25 and 2:10. Now, if you're looking at this schedule, which has all the information about what goes on for the week, and you're thinking, I would love to have this schedule and see this information for myself, well, here's where you can get it. It's in your work list. So if you open up the work list, you'll see that link at the top, same floor class schedule. You're going to open that up and then you may need to pop it out in a separate window, and then you'll see the schedule here. Now, the reason why I call the same floor schedule is because I put in the times that I have planning. There are some times that all teachers have planning, but then there's just some times that I have planning, meaning that I will not be available during those times for support, okay? All right, so that's that. And then finally, to reminder that you can access the support. It's the bottom link in the homepage of your Schoology. And I will stay on the support hours for the first 30 minutes. If no one logs off, message me in Schoology. Now, it's important that if you do message me in Schoology, refresh your Schoology, because Schoology messages don't update frequently. So if you sent me a message, expect I'm going to send you one back as soon as I can. So you might want to refresh it if you're planning on coming. All right, next thing that we talked about were nuclear reactions. And we've learned so far what nuclear reactions are, the reactions that result in changes to the nucleus, and that could be the number of protons and neutrons. It can also result in the rearrangement of protons and neutrons, and that's through a process like gamma decay. So you arrange the protons and neutrons to a more stable or less energetic state. We also learned about types of nuclear reactions and how to balance them. So we're going to now do a quick review. This review will review balancing nuclear reactions, and it will review identifying the types. So here we have an example of 10-105. So SN is the symbol for 10. And we're trying to figure out, well, what will go here according to this nuclear reaction that will make sure this is balanced. Now remember, in order for the reaction to be balanced, the mass numbers, the total mass number on the left side and right side of the arrow must be the same, and the total atomic number on the left and right side must be the same. So for this first blank, I'm asking myself, well, I have the total mass number on the left side of the arrow is 105, since there's only this element here. That means that the total on the right side must be 105. Currently, I just have a 0. So 0 plus what will give me a mass number of 105? Of course, that's 105. So I know the mass number is 105. Now for the atomic number, if I look at the atomic number, on the left side, the total atomic number on the left side of the arrow is 50. And on the right side right now, I have a -1. So I'm asking myself, -1 plus what will give me 50? Now remember, because the number is negative, I'm going to have to be very careful about my math. Well, the answer to that, the atomic number that would go here would be 51, because 51 plus -1 will give me 50. So that gave me my two numbers. Now to find the symbol of the element, I need to go to the periodic table and look up the atomic number and figure out which one has 51. And for that, it will be Sb, which is antimony. So this is the unknown that we have here. Okay, now my question to you all is, well, what type of reaction is it? Is it fission, fusion, alpha decay, beta decay, or gamma decay? Now, one thing you might want to do is take a look at this. This is written as an electron, but this is actually also a very special symbol. And there's another word for this that we use. What do you think it is? That's right, beta particle. So a beta particle is just a high energy electron. And that high energy electron results when a proton becomes a neutron becomes a proton. Now you can also see them as different as, instead of an electron, they may use a beta symbol, beta being the Greek letter. And I had a slight correction, which I corrected here. And the bottom number, which is representing your nuclear charge, will be a -1 for an electron, since electrons are negative. And then the top number being the mass will be 0, since electrons have 0 mass. Okay, now that we know this is a beta particle, what type of reaction this is? This is known as beta decay, right? So this is beta decay because with beta decay, you start with one reactant. So you're starting with one thing, our reactant, and it splits apart into a nucleus and a beta particle. So it's going to split apart into two things, and one of those things will be a beta particle. Let's try the next one. This is for you now to try, now that we've gone through. So pause the video now and see if you can figure out what will go in this blank to fill in that empty space. Gamma particle, right. So remember, a gamma particle doesn't have a mass or a charge. It's actually just a high energy photon, which is like a form of light or electromagnetic radiation. So taking a look at this, what reaction do you think this is? Is it fusion, fission, alpha decay, beta decay, or gamma decay? That's right, this is gamma decay. And just like with beta decay, you start with one nucleus, right? And it splits apart into two different things. One of them will be a nucleus and a gamma particle. Now, one thing to note about gamma radiation, which is different from all the others, with gamma radiation, notice how you're starting with the same element and ending with that same element, right? You have Einsteinium on both sides. The only difference is that this Einsteinium had a lot of energy in its nucleus. And so it just released that energy as a gamma particle, which is a very high energy particle. All right, so we have our beta decay, gamma decay. Let's look at the last one. What will go in that blank to balance the equation? Right, another hydrogen. This is hydrogen 2. So when you add up the mass numbers on this side, you have 2 plus 2, which gives you 4, and 3 plus 1, which gives you 4. So the mass numbers are good. And then the bottom, on the atomic number, we have 1 plus 1, which gives us 2, and then 2 plus 0, which gives us 2. So that's good. So it's a balanced equation. Okay, now that we see that, the question is, well, what is this reaction? Is it fusion, fission, alpha decay, beta decay, gamma decay? Now, many of you may look at this and say, you're putting two things together, but you're forming two things, so I don't know. Well, let's take a closer look. In order for it to be a fusion reaction, fuse means to combine together, you start off with two or more reactants, right? Two or more nuclei. And they're going to form one nucleus, which will be larger than the other two, which is what we have here. Because remember, this is a neutron, and neutrons are not a nucleus. So even though this may be ejected when these two combine, you're still just forming one larger nucleus, so this is a fusion reaction. Okay, so now let's go into the last couple things we talked about, which is why are we studying nuclear chemistry? So couple of things. First thing, this is why the state mandates nuclear chemistry, is because nuclear energy may be a more important energy source than it is currently. There are places that are using nuclear energy, but with the depletion of fossil fuels, nuclear energy is a viable option. And that means that there will be future careers that people may be engaged in nuclear energy, so they want folks to be educated and see what it's about. As high school students. Also, if we are using nuclear energy, that's going to be incorporated into our daily lives. So they want people to have that language around that. As I mentioned before, we are learning nuclear chemistry in this unit because balancing nuclear equations helps us practice and apply nuclear symbol notation like this. And it also helps us with our essential question, which remember is alchemy a real science? Now, talking about alchemy, alchemists wanted to change cheaper metals to gold, right? So those base metals like lead and tin and copper. Now, to change the identity of an element, we need a certain number to change. Which number do we need to change the identity of an element? Is it the mass number, which is the top number, or the atomic number, which is the bottom number? We need our number of protons to change, so the atomic number to change, right? So that's the thing that we're changing. If you want to change the identity of an element, you have to change the number of protons. And that's what nuclear chemistry is all about. It's about changing the number of protons and neutrons in a nucleus. So in that demo where I turned a penny into a gold coin, quote unquote, you guys didn't believe that I did that. But the question is, can we actually do that? So in this final project, you're going to use your understanding of nuclear chemistry, which is changing the protons and neutrons in the nucleus, to propose a way, or also known as a mechanism, to turn a base metal, like lead or tin, into gold. All right, so now we're going to show you where you're going to get this information for this project. So in your course, if you go to Unit 1, we are in week 3, and the day was Wednesday. You're going to see this thing that says Unit 1 Final Project, graded. So this will be your graded final project assignment. You're going to open that up, and then you're going to open this up. Now for the final project, this is the document that you are going to submit. But at the very top, there's a link to a document that has more instructions. You're going to open that link to read the instructions. So I'll show you that once again. There's a link there at the top. You're going to click on that and open that up to read the instructions. Now, there's another video that I'll go through the instructions with you, so I'm not doing that here, but this is important information at the top, so you want to make sure you read it so you get a sense, and then also watch that video to see how to get started with this project. Now, you can do this project independently, or you can do it as in a group of no more than 4. If you are doing it in a group, you are going to have to detail your contribution, so make sure you read this section carefully to know what will be considered an academic contribution and what would not. Then at the bottom of this document, if you go through the steps of what you need to do in order to be successful, there are some helpful information. So if you want the periodic table that we've been using in class, there's the link for it right here. If you want to see the types of particles that you can use or in their symbols, there's the table here. And also I have a list of types of nuclear reactions. This is a ChemLibra text link. This information, or the most useful information for you, would probably start here at this table. It gives you a sense of the different types of reactions, because you can use more than just alpha, beta, gamma decay, and fusion and fission. You could use the ones that are shown here. That's totally up to you. The main thing is you have to use the 5 that we're learning in class. And so after the table, they give you examples, more specific examples of different types of reactions. So you can use that as a guide if that's helpful. Okay, so final thing. So in doing this work, you're going to turn a base metal into gold, and you have to make sure you do that in 7 steps. And you have to, let me go just to the instructions page again, you have to label each of the steps. So this only has 4 steps. You need to do that in 7 steps, okay? Well, that is it for this video. I hope you found it helpful. If you want more details on how to get started, there will be a second video for today. All right, folks, have a quality day.